Alright, so now we've looked at, or we're introduced to the three extra functions, trig functions in the previous video. We can actually now use those to do some more proving and solving for theta or x. So this is what we did in actually Pure 1, the book 1, right? So it's just the same method, but now we're just dealing with some extra, or using extra terms. So first comes first, let's look at some of these proof equations. So let's try starting off with A. Okay, so let's say, prove that cos theta plus sine tan theta is sec theta. It's the same method, right? It's just left-hand side and then try and make it to right-hand side. So starting off with left-hand side, cos theta plus sine theta tan theta. And the trick here is, well, we just want to make everything into sine and cos. That's like an easy order. That's like a tip that you should always try and do. Just make it into sine and cos. So I'll change it into cos theta plus sine theta. So tan can be sine over cos, right? So it's going to be like this. After this, we just try and make it into one fraction if possible. So multiplying cos across, so get cos squared theta plus sine times sine is sine squared theta over cos theta. We know cos squared plus sine squared is 1, that identity we learnt in the first book. So it's going to be 1 over cos theta, which is sec theta, which is equal to the right-hand side. So just try and make everything to sine and cos and then just rearrange from there. We can try another one. Let's try C here. So cosec theta minus sine theta. And we're going to try and change that into cos cot theta. So once again, try and change it to sine and cos if possible. Cosec we know is 1 over sine theta, right? Minus sine theta. After we do this, try and make it into one term by making it all into like one fraction. So we're going to have 1 minus sine squared theta over sine theta, which is 1 minus sine squared, using the identity again, is just cos squared theta over sine theta, which is equal to cos theta times cos theta over sine theta, which is cos theta cot theta, which is what they wanted in the proof, as you can see. We can try one more. Maybe let's just try F as well. So cos theta over 1 plus cot is sine over 1 plus tan. So left-hand side, cos theta over 1 plus cot. Once again, first things first I like to do, change it to all in terms of sine and cos. So it's going to be cos theta over cot, remember, is cos over sine. Okay, and from here, make it into one fraction. So we're going to have cos theta in the numerator, and we're going to have sine theta plus cos theta over sine theta. We can simplify this even further by saying it's going to be cos theta sine theta over sine theta plus cos theta. Right, from here, you have to now see what we're trying to make, right? So they're asking us to try and make it into sine 1 plus tan. So we want to ideally make this numerator to sine, and the way we can do that is actually multiply it by, or divide it by 1 over cos. That way we're left with sine in the numerator, right? Which means we should do the same thing for the denominator as well. So we're going to have cos theta sine theta over cos on the numerator. On the bottom we have sine theta plus cos theta over cos as well. And as you can see, there will be some cancelling out. So these will cancel out, right? And so you're left with sine theta in the numerator. On the denominator, we have sine over cos like this, because we're dividing each one separately. Sine over cos is tan, and cos over cos is 1 plus 1, which is equal to the right-hand side, which they wanted you to find. So the proving part is not too difficult. Just go by the rule that change it to sine and cos terms, make it into one fraction, and try and see how we can create it into the right-hand side. Right, we can also actually try and find theta values or x values in a certain domain. So this, once again, is just as we did in Pure 1, just trying to find these angles, but we have to deal with these extra trig terms. So let's just try maybe question H. So 2 cot squared theta minus cot theta minus 5 is equal to 0. Once again, it's in a quadratic form, so I can factorize it. So we're going to get 2 cot theta. And then we're also going to have, in one bracket, cot theta. This is going to be minus 5 plus 1 equal to 0. So we can have cot theta is equal to negative a half, or cot theta is equal to 5. Right, from here, this is where it slightly differs. We don't have the cot theta function in our calculator, right? So instead, we're going to change it to tan by flipping it. So we can say that tan theta is, flipping this is negative 2. And tan theta is 1 over 5. Because tan is 1 over cot, right? So I can flip both them upside down. And from here, I can work out my theta values respectively. Right? So this is going to be minus 63 over 4. And this is going to be 11.3 degrees. And then we use the cast diagram that we learned in Pure Book 1. So if you have forgotten about that, maybe go back to that video and just remind yourself again. So for this one, theta is 63.4 CAST. Tan theta is a negative, so it's going to be in the S section and the C section. And these angles are going to be 63.4, 63.4. For when theta is 11.3, once again, cast diagram. Tan is a positive value here, so that's going to be now in the A section and T section, where here is 11.3 and here is 11.3 as well. So these angles, we just have to make sure that what the range is, or the domain is between 180 and minus 180 and 180. So we get in here, this first one, we can have, we're starting off at 0, right? And we're going clockwise, so we know clockwise is negative. So we're going to have 0 minus 63.4. This one here is going to be from 180, and we're going clockwise again, so we're going to subtract it. So 180 minus 63.4. These values, this is 0, and we're going anti, which is plus, so 0 plus 11.3. And this is 180, but if we plus it, we get bigger than 180, right? So we can also say it's negative 180. And once again, we're going anti-clockwise, so plus 11.3, and these will be your 4 answers. We can try one more, so maybe let's try G as well. So cosec 2 theta is 4. So it's the same method as we just been doing. So cosec 2 theta is 4. Remember, when it's anything other than a theta term, we introduce a new letter saying that, let's say, let capital A equal to 2 theta. So therefore, cosec capital A is equal to 4. Once we've done this, remember, we can't forget about the domain, right? So for theta, it was between minus 180 and 180. But because we changed it to A, we need to create its own new domain. So just times, because A is 2 theta, just times theta by 2. So for A, the domain will be from minus 360 to 360. Just remember, you don't forget these others, we might lose some solutions. But from here, cosec is 1 over sine. So sine A is just 1 over 4. And A is inverse sine 1 over 4, which gives us 14.8. We draw a cast diagram. CAST. Sine is a positive 1 over 4, so it's going to be the A section and it's going to be in the S section, whereas 14.8 and 14.8. And remember, now we have to look at the domain. So it's from minus 360 all the way to 360. So let's start off with minus 360. So A is going to be, minus 360 is going to be here, and we're going anti-clockwise, so we're going to be adding 14.8. The next one is minus 180. And we're going anti-clockwise this way here, right? So it's going to be negative 14.8. We keep going around, so now it was minus 360, now this is going to be 0 again. So 0 plus 14.8, rotating again, this would be positive 180, 180 minus 14.8, and 360, so it's up to that point here, right? So these are the 4 solutions, but remember, these are the solutions for A. We need theta, and theta was A over 2, right? From the initial beginning here, theta is A over 2. So make sure you divide each of these values by 2 and you'll get your theta value. So working out, the last part of the question is just the same as pure 1. It's just initially, which if we had dealt with some cosec terms here or some cot terms, we just have to flip the values around just in order that so we can find the actual angles using the calculator. So maybe if you guys just give a couple of these questions a go yourselves, or just practice some questions in the textbook, and just start getting used to just dealing with some of these new trig rules.